Okay, so number 10 from the back of your packet, find the area of the shaded region. So just start with a general formula. We're going to take the area of the full circle, and I'm going to subtract out the area of the triangle. All right, circle first here. Circle is pi r squared. Unfortunately, the 5 radical 2 is pointing to a chord and not the diameter or the radius, so I can't use 5 radical 2. But I can use it to get to the diameter. So I have 5 radical 2. The markings say these are congruent, so here's 5 radical 2 meters as well. There's a couple ways we could approach this. We could now do Pythagorean theorem to find the diameter. Well, Mr. Carlino, how do you know it's a right triangle? Because this down here, this angle right here is a inscribed angle drawn to a diameter. So we know from last unit that that is a right angle. Okay, so that's got to be a right angle. So I can do Pythag, or I can notice that, hey, if those sides are congruent, this is also isosceles. So the angles across are equal, right here and right here. And they have to be 45 and 45. So I do have a 45, 45, 90 triangle. So I don't, whatever you guys are comfortable with, whether it's using your 45, 45 or Pythagorean theorem, it's up to you. I guess I'll use Pythag since I said it first. So 5 radical 2, make sure we square it all in our calculator, just not the radical 2. Plus 5 radical 2 all squared equals c squared, the hypotenuse. I can plug this right in my calculator, 50 and 50. Hold on, 50. Yeah, 50 and 50. 100 equals c squared. C equals 10 now. Okay, so C equals 10. That's the diameter length, 10. Radius would be 5. So the area of that circle is 25 pi. All right, what about the area of the triangle now? And, I just got done correcting all the tests from today. I don't know why, but too many. It wasn't many, but too many for my liking. It's 1/2. A lot of people forgot the 1/2 BH. All right, it's 1/2. I'm not too sure why, but too many for my liking. 1/2. Since this is a right triangle, the base and the height are your legs. Anytime you're dealing with the right triangle, the base and the height are the two legs. So 5 radical 2, 5 radical 2. Oh boy. Let's see, that's 25, that's 50. I think this comes out to be 25. All right, so the area of the shaded region now is going to be 25 pi minus 25. And whatever the directions were, round to the nearest tenth. If it said leave your answer in terms of pi, this is where I'm at right now. This is in terms of pi right now. Okay, that's in terms of pi. But if it said nearest tenth, obviously we go to the calculator and subtract. All right, so there's number 10 from the back of the packet. Other specific questions, topics you want to cover? Again, let me just put up the topics.
Yep. Can we go over the properties for the rhombus and kite that we need to know?
Yep. So let's do rhombus first. Let me actually get a rhombus, so as we do the properties, I can mark them and show you why you would need them. So let's get a rhombus. We'll say that's a rhombus, even though it's a parallelogram. All right, on property number 1, all sides congruent. Okay, all 4 sides congruent in a rhombus. You really want to worry about the diagonal properties. Diagonals are perpendicular. All right, the diagonals are perpendicular, and that helps because I can now use Pythag if I wanted to. I can now use sine, cosine, tangent if I wanted to, because now I have 4 right triangles inside. And then the other one that's definitely going to help you is diagonals bisect each other. Okay, so I feel those, I know there are more properties with a rhombus, but I feel like those are the 3 that'll definitely help you out. Diagonals bisect, so those 2 are equal. And then I should probably be more neater on that. And then 1, 2, 3. Okay, diagonals are not congruent, but they do bisect each other and they are perpendicular. Again, that's helpful because now you can say, all right, I can use Pythagorean theorem on one of those right triangles, or I can use sine, cosine, tangent on one of those right triangles. All right, and then kite. I don't have a kite up here, but why don't we flip this a little bit? How about that? That's not going to work. All right, I'm just going to have to go old school. Okay, with the kite, adjacent sides congruent. All right, 2 properties that'll help you with the kite. Diagonals are perpendicular. And longer diagonal bisects the shorter. So there's my longer, there's my shorter, bisected, and perpendicular. Again, why would I need to know that? Well, Pythagorean theorem, because you have 4 right triangles again, and then sine, cosine, tangent. That's why it's good to know diagonals are perpendicular in any figure. You can probably use Pythag or sine, cosine, tangent with them. All right, so there's rhombus kite.
Thank you.
Yep, no problem. Other topics, problems we want to touch upon.
Can we do a problem with sine, cosine, and tangent?
Absolutely. Here we go. Where are they? There we are. This is coming, if you guys, this is coming from your textbook now. Page 833, number 11. Area of this parallelogram now. Okay, area of the parallelogram. So first thing, formula. Area equals base times height. It looks like the base is already given here, 13. Opposite sides are congruent in a parallelogram, so this is also 13. And here's my height, which we're going to have to find. So I have 13 times, let's find the height now. All right, it is part of a right triangle. I do know the hypotenuse of that right triangle is 9. And a little property we haven't talked about in a while for parallelograms, that's 65, and that angle 65. Opposite angles in a parallelogram are congruent, so that would make that 65. Perfect. Now that I have an angle and 2 sides, I can do sine, cosine, tangent. I already mentioned that the 9's your hypotenuse, so I'll put a little h in parentheses there. And my height is opposite the 65. The height's opposite 65. So if I have O and H, I look at SOHCAHTOA here, because that'll help me determine which one of the 3 I use. I have O and I have H, so I'm going to use sine ratio. So the sine of 65 is equal to opposite side H over hypotenuse 9. Opposite over hypotenuse. I'm going to put this over 1 to remind me I need to cross multiply. So height is equal to the sine of 65. Make sure my calculator's in degree mode. Times 9. Don't round it, don't round it, don't round it. Keep it in my calculator and multiply it by 13. Okay, using sine, cosine, and tangent. Where it's not, and I know I'm going to have to use sine, cosine, tangent if I get an angle that's not 30, 60, or 45. Automatic giveaway that it's got to be sine, cosine, tangent if I don't have a special right triangle on it I'm working with. Just some things that are coming to my mind. Please make sure in your packet you review the very last question we did as a class on Big Al and his deck that's in the shape of an octagon on page 20. All right, there will be a question similar to that on the test, except you're going to have to do something with this garage, but still it's, how many square feet is the garage? All right, what if I need to paint the garage? How many cans am I going to need and how much is it going to cost? All right, very similar to this question right here on page 20. So just make sure you just review, all right, if I'm, do I need to multiply? Do I need to divide? And remember, you can only buy whole things at the store, everybody, okay? Whole things at the store. Can't buy partial bags of seeds or partial cans of sealant. It's got to be full cans. Other topics, questions, concerns? Know your formulas. Your 30, 60, 90, 45, 45, 90 rules. And just be aware of what you're dealing with. If you're dealing with a half circle, make sure you don't use pi r squared. It's pi r squared divided by 2. It's really about all I have to warn you about. What else you got for me here, guys? Ladies, what else you got?
Can you do a 45, 45 or a 30, 60, 90 question?
Absolutely. For you, Nate Dogg, anything. Let's see. Do I have any on hand? Probably not. Here. That's trig. All right, how about I'll take this one we did for the win random stuff game, but I'll change that 30 to a 45 now. So we get a little practice here because we already did it using 30, 60, 90. Let's change it to 45 degrees now, that angle. Okay, on page 804. Let's see, and we won't have to leave it in simplest radical form. We can just go nearest tenth. So area of a parallelogram again, base times height. I already know this side's 14 centimeters. So there's my base. I just got to work on the height now. All right. So in that 45, 45, 90 triangle, I know the hypotenuse is 26 centimeters. So let's go over the rules of a 45, 45, 90 again. Legs are congruent. And here's the one we're going to need. Hypotenuse equals leg times radical 2. Radical 2. I know the hypotenuse is 26. You're looking for the height, which is across from one of the 45. So that's a leg. So I'm going to put h in for leg times radical 2. All right, how do I get h by itself? I need to divide both sides by radical 2. And you don't have to worry about this tomorrow, all right, about getting the radical out of the denominator. I know some of you are worried about it, unsure. Some of you are good at it. Don't worry about it tomorrow. We haven't had enough practice with it for me to put it on the test. So what I would do from here is go right to my calculator, figure out what 26 divided by radical 2 is as a decimal, plug that right into my parallelogram formula, and multiply it by 14. Because if I do give you a question like this tomorrow, it'll be round to the nearest whatever. All right, the directions won't be simplest radical form for a problem like this. Because again, I don't feel comfortable in having you guys take a radical out of the denominator. We just haven't got that much practice, so I wouldn't do that to you. All right, but there's a 45-45 one using a parallelogram. Other questions, comments?
Can you do a question where we have to leave something in simplest radical form?
Sure. I'm trying to think, where can I? If I do ask that, it's definitely going to be something like a 30, 60, 90, 45, 45, 90. Let me go back to the packet. That's an octagon. All right, I'm going to see how this goes here. I'm going to take number 2, even though it says find the area to the nearest 10th. This is in the back of your packet, back of the review. And I'm just going to say, all right, we're going to find the area still, but now it's going to be in simplest radical form for this trapezoid. All right, so this is coming from the back of your packet. All I'm doing is just change the directions to simplest radical form. And I'm crossing my fingers it comes out to be okay. All right, so this is a trapezoid. So I get my trapezoid formula, 1/2 the height times the bases added together. I'll look at my diagram, and I have one base at least, which is 8. So I have 8 plus whatever that other base is. All right, here we go. So let me draw in the height. All right, once I draw in the height, I notice now, hey, I just made myself a 30, 60, 90 triangle. All right, this is also 8 inches down here. All right, so here we go. It looks like I'm given the side across from 90 is 12. We just went over the 45-45 rules. Why don't we go over 30-60 right now? Hypotenuse equals shorter leg times 2. Longer leg equals shorter leg times now radical 3. The 12 is across from the 90, so that's the hypotenuse. So that must mean the shorter leg is half of that, 6. And that must mean my my height is the longer leg. So I'll take 6 times radical 3. So 6 radical 3 for your height. Go back to your formula. Height, 6 radical 3. Other base, 8 plus 6, 14. All right, direction said simplest radical form, so let's clean this up a little bit. That's 22. All right, so now when I ask for simplest radical form, you can multiply anything you want here, but leave the radical 3 in your answer because that'll be simplest radical form. So I'm going to do 1/2 times 6 times 22. Multiply all those together. We're looking at 66. And then make sure we have units tomorrow. Square inches. So that would be simplest radical form. All right, I can multiply everything but whatever's with the radical I just put in the answer. So here is simplest radical form. Good question there. Good question. Good find too. Other questions, go ahead. We're okay. Where did I have it here? The regular figures, regular hexagon, octagon, multiply the area of one triangle times how many triangles there are based on the figure. Just make sure we're good with those. How to determine what the angle is, if it's going to be a 30, 60, or 45 degree angle, or something else that's going to require sine, cosine, tangent. Usually with the hexagon, this is not a hexagon, right? 1, 2, 3, 4, 5, 6. Yeah, this is an octagon. Remember, I just take the angle. I say, all right, 360 divided by how many there are, in this case, 8. So that's a 45 degree angle right here, 45 degrees. But when you draw your height in, it ends up bisecting that angle. All right, so now that 45 just became two 22.5 degree angles. Okay, when you draw the height in, it bisects the angle and also bisects your base, remember. That was the other thing, too, a lot of kids forgot was when you do the area of a triangle, 1/2 base times height, make sure you put in the full base. All right, I had a handful of kids today put in just half the base into the formula. It's the full base that goes in, okay, not half the base. And then I take that and I multiply it by how many triangles I could form in the entire polygon. Other questions, topics? Okay. If there's no questions, you guys know the deal. A lot of you guys have been here before. If you have something pops up in your mind or you have a specific question you want to reach out to me, go ahead and email me tonight. That's fine. No big deal at all. If I don't see it tonight, I'll see it early tomorrow morning and I can get back to you before school starts. If not, know your formulas and your properties and your special right triangle facts, right? 30, 60, 45, 45. All right, guys, good luck tomorrow. I'll see you guys then. Take care, behave, be smart.
Thank you.
You're welcome.
Thank you.
Yeah, no problem, guys. Thanks for coming.